A $2 liquid can destroy rust once it's already there. That sounds impossible. It isn't. Because rust isn't just damage, it's an industry. Every flaking surface, every corroded pipe, every replace instead of repair moment feeds a cycle that keeps people paying, again and again. By the time metal turns orange, most people assume the outcome is locked in. Repair, replacement, cost. But that assumption is where everything shifts. Because there is a liquid. It costs about $2. It doesn't require a mechanic. It doesn't require a shop. And it doesn't prevent rust. It reacts with it. At a chemical level, it transforms active corrosion into a stable, protective layer. The damage doesn't just slow down. It changes form. On paper, that shouldn't be enough. A $2 fix for a problem that drives massive repair cycles across entire industries shouldn't exist. And yet, it does. Which raises a more uncomfortable question. If a solution this simple can neutralize something this widespread, why isn't it what most people reach for first? Not unknown, not restricted, not complicated, just strangely absent from the places you'd expect. Welcome to Trust No Instinct. If questioning incentives matters to you, subscribing keeps this thinking alive. This isn't new. The chemistry behind this has been understood for a long time, long before it ever appeared in consumer products. Long before rust removal became something you buy in a bottle, there was already a different approach. Don't remove it, transform it. Because rust isn't just damage, it's a chemical state, and that means it can be changed. At the center of that idea is tannic acid, a compound that reacts directly with iron oxide, the material we recognize as rust. When applied to active corrosion, it doesn't clean the surface, it converts it. The unstable iron oxide becomes iron tannate, a darker, more stable compound that slows further reaction and forms a protective barrier, not cosmetic. Chemical. And this didn't stay theoretical. It was pushed into environments where failure wasn't an option. By the mid-19th century, British naval engineers were already using tannin-based treatments to slow corrosion on iron hulls, because when rust spreads across a warship, you don't get a second chance to fix it at sea. A century later, the stakes got even higher. During World War II, the U.S. War Department tested hundreds of anti-corrosion compounds to protect military equipment in extreme environments. Among them, tannic acid-based treatments didn't just perform. They outlasted many synthetic alternatives under prolonged exposure conditions, designed to simulate harsh, corrosive stress. Not a workaround, a proven method under pressure. And it showed up anywhere starting over wasn't practical. Restoration work, industrial maintenance, heavy equipment, systems where shutting everything down to strip, replace, and rebuild wasn't just expensive. It was disruptive. Because in those environments, one principle was already clear. Starting over is expensive. Keeping something running is everything. And that's where the pattern begins to widen. Because corrosion doesn't just degrade metal, it drives a cycle. Inspection, failure, repair, replacement, repeat. Entire product ecosystems are built around that loop. Coatings, treatments, parts, services. Not once, but continuously. And a method that stabilizes rust in place. Doesn't fit that loop. It short-circuits it, quietly, but directly. Which is why what happened next is harder to ignore. Because the chemistry didn't disappear. The reaction didn't stop working. High-stakes environments didn't abandon it. But it never became what most people are told to do first. After large-scale manufacturing and chemical production expanded in the mid-20th century, the dominant approach shifted toward repeatable treatment systems, products designed to be reapplied, replaced, and repurchased over time. And when you line that up with the scale of the corrosion economy, how many products depend on rust returning, how many systems rely on maintenance cycles continuing, the absence starts to feel deliberate, not openly blocked, not publicly denied, but consistently overshadowed by solutions that keep the cycle going. And once you see that shift, it's difficult to look at rust the same way again. The solution didn't disappear. You've been buying it this whole time, just not under its real name. Because the same chemistry we've been talking about, the same tannic acid reaction that converts active rust into a stable barrier, is still sitting on store shelves, rebranded, repackaged. marketed as advanced rust converters or proprietary corrosion systems. But strip away the label. It's the same reaction. And the price difference is where it stops feeling accidental. Because what starts as a low-cost natural compound is often diluted, relabeled, and sold back at 10, sometimes 15 times the original cost. The same core mechanism, wrapped in technical language, positioned as something specialized, something you shouldn't question. And it doesn't stop there. In some cases, that same process is sold as a service, applied in minutes, explained in vague terms, and priced hundreds, even thousands of dollars, depending on the context. Same chemistry, different story, much higher cost. And here's where it sharpens. Since the late 20th century, labeling practices have shifted. Instead of clearly naming tannic acid, many products lean on broader, more complex descriptors, terms that sound proprietary but often point back to the same underlying reaction. Not illegal, but not obvious either. And once you see that, the mechanism becomes harder to ignore, because at its core, this isn't complicated. Tannic acid reacts with iron oxide. It forms iron tannate. It stabilizes the surface. That's the process. And in its simplest form, it can be recreated. Carefully, precisely, without branding. A commonly used ratio is about 4 grams of tannic acid powder to 100 milliliters of warm water. Mixed properly, the solution takes on a dark, tea-like color. Applied to rusted metal, the reaction begins almost immediately. Within minutes, the surface shifts from reddish-orange to a darker blue-black as iron tannate forms. Not paint, not coating. A chemical conversion. Within 10 to 15 minutes, the change is visible. Given time, the layer stabilizes further, creating a base that can be left as is or coated over for additional protection. But this isn't magic. Surface preparation still matters. Thick, flaking rust needs to be reduced so the solution can reach the active layer beneath. Coverage needs to be even. And expectations need to be realistic. It stabilizes rust. It doesn't restore metal that's already gone. Still, once you understand the reaction, the pricing, and the packaging, it becomes a different kind of question. Not how to fix rust, but why the simplest version of that fix was made to look like something you had to buy back at a premium. And this is where it stops being about chemistry and starts becoming about incentives. Because once you understand that a $2 compound can stabilize active rust, the entire repair cycle starts to look different, not just for you, but for the system built around it. Rust doesn't just damage metal, it generates demand. Every time corrosion reappears, something gets sold, a new coating, a replacement part, a service package, a treatment plan. The cycle resets and the transaction repeats. Inspection, failure, repair, replacement, repeat. That loop isn't accidental, it's the foundation, because a problem that comes back is a problem that pays, and a solution that stops it from progressing, disrupts that flow, quietly, but completely. This is where things start to feel uncomfortable, because the value of most corrosion-related products isn't in eliminating the problem permanently. It's in managing it, slowing it, keeping it just controlled enough that it doesn't fail immediately, but not resolved enough that it never returns. That balance sustains the system, not a conspiracy, a structure. But structures have priorities, and a method that converts rust into a stable layer, one that doesn't need constant reapplication, one that reduces the need for repeated intervention, doesn't align with those priorities. It reduces touch points, it reduces repeat purchases, it reduces dependency, and that creates tension, because from a user perspective, that's efficiency. From a system perspective, that's erosion of revenue, so the market adapts, not by removing the chemistry, but by repositioning it, wrapped in branding, diluted into product lines, embedded inside systems that reintroduce the need for maintenance. Same reaction, different role. Instead of ending the cycle, it becomes part of it, and over time, that shift becomes invisible, because most people never see the underlying mechanism. They see categories, products, instructions, recommendations that feel standard because they've always been there. But if you trace it back, the core solution never required that complexity. And this is the part most people don't sit with long enough, because once you see how a simple, low-cost method interacts with a high-frequency maintenance cycle, the pattern becomes harder to ignore, not because anyone needs to hide it in plain sight, but because the system doesn't need to promote what disrupts it. And that distinction matters because it changes the question from, how do I deal with rust when it shows up, to, why was I never shown the version that changes what happens next? And once that question settles in, it doesn't just apply to rust, it starts to echo across other problems, other products, other systems built on the same quiet loop. And that's where the perspective shifts, not dramatic, not loud, but difficult to reverse. So, what does this actually look like in the real world? Not theory, not branding, a result you can point to. In 2019, a mechanic in Montana tested this on something most people would have given up on, a rusted truck frame from the late 90s, heavy corrosion, years of exposure, the kind of damage that usually leads to one conclusion: replace it or let it fail. Instead, he treated part of the frame with a tannic acid-based solution, not the whole thing, just a section. The rest was left untreated. Then winter came, road salt, moisture, freeze-thaw cycles, the exact conditions that accelerate corrosion faster than almost anything else. Month after month, both sections were exposed to the same environment, and that's where the difference showed up. Within the first year, the untreated metal began rusting again, spreading, flaking, degrading just like before. But the treated section didn't behave the same way. The surface had darkened, stabilized. The corrosion didn't continue to expand in the same pattern, same truck, same winter, different outcome. And the process behind it wasn't complicated. You're not removing rust. You're changing what it is. Loose flaking layers are reduced so the solution can reach active corrosion. Then it's applied evenly across the surface. Within minutes, the color begins to shift, orange turning to deep blue-black as iron oxide converts into iron tannate. You can see it happen. And once it sets, the surface stops behaving like active rust. No machinery, no complex system, no built-in repetition, just a reaction doing exactly what it's supposed to do. I need to be completely honest here. This doesn't reverse structural damage. If the metal is already weakened to the point of failure, cracking, thinning, breaking apart, this won't rebuild it. It stabilizes what remains, nothing more. And it only works where it can reach. If corrosion is sealed beneath layers, hidden inside joints, or completely inaccessible, the reaction can't take place. This is not a universal fix. It's a precise one. But within that scope, it does something most people never expect. It stops rust from continuing once it's already begun. So, in the end, this was never just about rust. It was about what happens when a simple solution collides with a system built on repetition. Because nothing you've seen here is hidden in the traditional sense. The chemistry is known, the materials are accessible, the reaction is predictable, and yet, the version most people encounter is the one that keeps the cycle intact. Not because it has to be that way, but because it works. For the system. That's where the tension settles. A problem that returns, sustains value. A solution that stabilizes it, quietly removes it. And those two things don't coexist comfortably. So the outcome isn't dramatic. It's subtle. The simpler version doesn't disappear. It just stops being the obvious choice. And over time, that becomes invisible until you see it. Because once you understand that a $2 compound can change how a billion-dollar problem behaves, you start asking different questions, not just about rust, but about anything that seems to require constant fixing, anything that comes back, anything that keeps you paying, and that's where the pattern begins. Not loud, not extreme, but everywhere.